So here's the most complex example that we're going to see not only today, but perhaps this entire semester. We're about to learn some new tools that will help us to solve problems like this a little bit more easily. And so we'll look back on this and say, wow, that was a pretty arduous task that we completed there, but it was a good task and one that we learned an awful lot from. So here we're faced with a problem where we need to find two voltages, V1 and V2, both of which, of course, are relative to ground. So there's V1 and there's V2 and there's ground. So I can label V1 as being across this resistor and V2 as being across this resistor. We're also asked to find I1, I2, I3, and I4. And I4 is shown up at the top, but it's also good to know that I4 could just be written down here as well. Now, when I'm looking for things that I could combine in the original circuit, I can see that the 8 ohm and the 7 ohm resistors are in series with one another. And I can see that these two resistors, the 7 ohm and the 2 ohms, are in parallel with one another. So I'm going to redraw the circuit. I'm going to redraw it pretty big because we're going to have a lot of things to do with this circuit later. So I'm going to go ahead and redraw the circuit here. I've got the 12 volt source and it goes into a 3 ohm resistor. And then it comes down into a resistor here. And I'll just mention up here, 7 in parallel with 2. That's 14 divided by 9. That's going to be 1.556 ohms. There's 1.556 ohms. This, of course, unchanged, still at 3 ohms. Then I'm going to have a resistor here, which is 8 ohms. And then a resistor coming down here is 6 ohms. And then the 8 ohms in series with the 7 ohms, that's going to give me a resistor over here, which is 15 ohms. Now the question is, which of our original variables can still be labeled in this diagram? Well, V2 is clearly still across the 6 ohms. V1 was across both the 2 ohm resistor and the 7 ohm resistor. Because those two resistors were in parallel, it was across both of them. And when we combine them in parallel, it's also across the parallel combination. So we can still label V1. I1 and I2, though, they're both gone. I1 was only through the 7 ohm resistor, which is gone. I2 is only through the 2 ohm resistor, which is gone. So those are both gone. I sub 3 can be labeled through the 6 ohm resistor. And I sub 4 was the current through both the 8 ohm and the 7 ohm resistor. So it is also the current through the 15 ohm resistor. So hopefully by seeing several more examples like this, it's making it a little bit easier to see how we progress with this work. Now I can go ahead and combine the 15 and the 6 in parallel. Sadly, I think that's the only improvement that I can make in this round. So I'm going to have 15 in parallel with 6. That's going to be 90 over 21, and that's going to be 4.286. So 4.286 ohms. And I can then redraw the circuit here. I'm going to have 12 volts going into 3 ohms and 1.556. Here's 8 ohms, and then there's just going to be one resistor on the end, and that's the 4.286 ohm resistor. And then here's the 8 ohm resistor, and 1.556 ohm resistor, and the 3 ohm resistor. And what can I still label? Well, I've still got V1, let's see, V2 is not only across the 6 ohm resistor, but V2 is also across the 15 ohm resistor. So I can still label V2 as being across the combination of those two resistors, but I3 and I4 are both gone. So unfortunately now we're down to just 2 of the original 6 variables that still remain, and I have to progress to a second page. I'm going to combine the 2 resistors in series, and so I end up with a circuit that looks like this. So here's 12 volts, and I have the 3 ohms. Here's the 1.556 ohms, and then this is going to be the series combination, 8 plus 4.286. I can do that in my head. I said I could do it in my head and then I didn't. 12.286 ohms. And then this is still 1.556 ohms. This one is 3 ohms. Write that more clearly. And this is still V1. But when I combine these, the 8 and the 4.286, the 4.286 was the only one that had V2. So V2 can no longer be labeled on this version of the circuit. Just a couple more steps to go here. So I'm going to combine those two resistors in parallel. And if you're really confident, you could go ahead and do both of these steps in one step, but I'm going to do them in two separate steps to try to make it easier. I have 1.556 in parallel with 12.286, and that works out to be 1.381 ohms. So 1.381 ohms, and here we have 3 ohms, and here we have 12 volts, and V1 was the voltage across both of the resistors that we just combined in parallel. So V1 is still, it's persisted all the way to the end here. It's still that voltage right there. Notice that at this point, if V1 was the only thing we were looking for, we could now solve for V1 using just voltage division, because we have 12 volts being shared between two resistors in series. But it's not the only thing we're looking for, so we'll find V1 on our way to finding everything else. Last thing that we're going to combine here, we've still got the 12 volt source and the two resistors in series. We're going to end up being 4.381 ohms. And we've now simplified that big, massive circuit down to a single voltage source and a single resistor. We've reached the midpoint of the problem. Remember the idea of the hourglass. So we are now done with simplification, and it's now time for re-expansion. So I'm going to switch ink colors. I'm going to go to, I think that red and blue is easier for some people to see than red and green, so we're going to go with red and blue. I need to identify a new current. Now, the numbers were used. The problem statement listed I1, I2, I3, so I'm going to call this I sub A. You could also call it I sub X, I sub Y, I sub Z, whatever you want, but I can calculate I sub A is 12 volts divided by 4.381 ohms, and that works out to be 2.739 amps. I sub A, I'm not going to box it because that's not one of the variables that we were asked to find, but it is an essential part of finding the variables that we were asked to find. I'll relabel I sub A in the next circuit diagram up. So there's I sub A, and as soon as I do that, I see that I sub A is also the current that's going down this branch. So there's I sub A as well. And if that's I sub A, and if this is 1.381 ohms, then I can find V1. V1 is equal to I sub A times 1.381 ohms, and therefore V1 is equal to 3.782 volts. 3.782 volts. So that's V1. Now, we can go back up one step further. Here's I sub A. And I'm going to go ahead and label the other two branch currents now. This one will be I sub B, and this one will be I sub C. And it will be beneficial for us to calculate each of those. So I'm going to go ahead and do that over here, a little bit more compact than usual. So I sub B is going to be equal to I sub A times the opposite branch, and that's 12.286 ohms, divided by the sum of the two branches, 1.556 plus 12.286, trying to squeeze that in there, and I sub B turns out to be 2.431 amps. Still not one of the variables we were asked to find, but we're on our way. And then I sub C, similarly, is going to be I sub A times the opposite branch. In this case, that's 1.556 divided by 1.556 plus 12.286. And this works out to be I sub C is 0.308 amps. Now, those are not boxed, but I'm going to draw arrows to them because I'm going to need them in the next step. Okay, speaking of the next step, I can now move back up, and I have I sub A is right here. I sub B is flowing downward through the 1.556 ohm resistor. And I sub C was flowing through the 12.286 resistor, but that's really just the combination of the 8 ohms and the 4.286. Because that's a series combination, they have the same current through them, so I sub C can be labeled at every point in that series combination. Now I can calculate V2. So V2, which is one of the things we were asked to find, V2 is equal to I sub C times the resistance, 4.286 ohms. V2 then works out to be 1.32 2 volts. And finally, I get to box another answer. So we've now found V1, which is down here, and we found V2, but we still have 4 currents to calculate. We're real close because we know all of the lettered currents. Now we just have to find all of the numbered currents. So I'm going to go back up to the first circuit diagram that I drew. Here's I sub A. I sub B is still here. This is still I sub B, and I sub C. Now I sub C in the third version of the circuit flowed through the 8 ohm resistor and through the 4.286 resistor. But the 4.286 ohm resistor is no longer present, but the 8 ohm resistor is. There's my landmark that tells me where I sub C goes. I sub C goes right there. And now I can use current division. So I can, and I've kind of not left myself very much room here, but I can calculate I sub 3. I sub 3 by current division is going to be I sub C, because notice that I have I sub C coming in, I sub 3 coming out, and I sub 4 coming out. So I sub 3 and I sub 4 are sharing I sub C. So I sub 3 gets 15 ohms in the numerator, divided by 6 plus 15 ohms, 6 ohms plus 15 ohms, and I sub 3 works out to be 0.220 amps. Box it, because that's one of my final answers. I sub 4 is equal to I sub C times, and for I sub 4, that's going through the 15 ohm resistor, so the 6 ohm resistor is the opposite branch. This is 6 plus 15, and that works out to be 0.088 amps. I ask myself, do those two currents add up to 0.308 amps? Yes, they do. And does the larger resistor get less of the current? Yes, it does. So now I can go back up to the original circuit diagram, and you can see here that I sub 4, got it. I sub 3, got it. V sub 2, got it. V sub 1, got it. The only thing that's really left here is V1 is I1 and I2. But I know V1. Remember that V1 is the voltage across each of those 2 resistors. So if I know the voltage and if I can divide that by the resistance, I can get the current. So I'm going to squeeze this right in here. I1 is going to be V1 divided by 7 ohms. And that's going to be 0.540 volts. And I2, I am literally out of room, is V1 divided by 2 ohms, and that works out to be 1.891 amps. And so now we've found I1 and I2. We've solved the entire problem. It took a lot of work. I'm not going to lie to you. Even I think that this problem was a little bit tedious. But this is kind of the most complex problem that we're going to look at in this course. We will see other problems that will look worse than this one, but by the time we get there, we'll have a more complete tool set, so those problems will be easier to solve.